तो हम पढ़ रहे थे माइक्रोस्पेक्ट्रोस्कोपी हो गई अपनी, अब अपने को पढ़नी है द इंटेंसिटी ऑफ स्पेक्ट्रल लाइंस। देखो अपने को क्या करना है, पॉपुलेशन लिखना है, हाई एनर्जी वाला में, तो अपने को क्या लगाना है, मैक्सवेल बोल्ट्जमैन स्टैटिस्टिक्स लगानी है, एन जी बाई एन नोट मीन्स इनिशियल, और ये अपर लेवल exponential minus delta by kt, so it will be exponential minus eg by kt. So what will be the relative population with respect to each other level? So ng by n not equal to exponential of what was the eg was minus bj j plus 1 into hc. If we are measuring this in centimeter inverse, we will use bsc, and if we are measuring b in joule, then we use only b. So ng by n not equal to exponential of minus bj j plus 1 hc by kt. Now suppose we have given that b, our constant rotational constant is given as 2 centimeter inverse, and we have j equal to 1 at t equal to 300 Kelvin. Then what will be the population, relative population with respect to ground level and first excited level? So exponential of minus b j plus 1 sc by kt. So minus b j plus 1 sc by kt. When you put the value, you will get 0.98. Okay, now next question. Now the intensity of spectral lines are depending firstly on population of energy levels, and secondly intensities are depending on degeneracy of energy levels. Now in general, the energy levels with values j, which is rotational quantum number, with values 2j plus 1 for degeneracy is directly proportional to 2j plus 1. Means that if there is 2j plus 1 degeneracy, then the population, relative population directly proportional to the 2j plus 1. Okay, what is the degeneracy? Degeneracy difference linear independent eigenvalues we are having, and we know that different linear independent eigenfunctions are sharing same eigenvalue. For same e, there are multiple eigenfunctions which should be linear independent. Okay, linearly independent. Then we called that the function, the energy value eigenvalue is degenerate. And how many functions we have? Suppose we are having 5 functions with same energy eigenvalue, then we have 5-fold degeneracy. So in this case, if j is the energy level, then the degeneracy we are having is 2j plus 1. Okay, so population is ng by n naught equal to, we have studied this from Maxwell Boltzmann, and now we have studied it direct proportional 2j plus 1. So combined effect on intensity will be ng by n naught, means the population, relative population will be a 2j plus 1 and exponential of this part. So this function can be represented h equal to f dot g. So h depends on f and g. H is linear dependence for j, and this is exponential dependence, which is exponential decreasing function. So for lower values of j, the linear dependence will be effective and this will be negligible. So for lower values of j, 2j plus 1 will be effective, and for higher values of j, exponential decrease will be come into play. So that's how the graph will be looked like. Okay, now relative population of ng by n naught will be nj. The graph of ng by n naught and j will be we are having this, this is the our graph. So for lower values, we are having the probability relative for 2j plus 1, and for higher values it is exponential decreasing. Now find out the nearest value of j for which the relative population is maximum. Now we have to maximize this. So what will we do? You will do differentiation with respect to j and put it equal to 0. From here, by doing so, you will get j maximum equal to under root kt upon 2bsc minus 1 by 2. Okay, this is the we are getting. Now isotope effect, we will now consider the isotope effect on rotational spectra. So we are having b equal to h upon 8 pi square ic, and if you do so, h upon 8 pi square and I equal to mu r square into c. We have studied this. This is the isotope effect on rotational spectra. Now suppose we are having two isotopes for carbon 12 and carbon 13. So you can see p is inversely proportional to mu. So mu 12 equal to 12 into 16 by 12 plus 16 for 12 CO compound, and for 30 CO compound it will be this and this. So you can clearly see here that mu 12 CO is less than mu 13 CO, or you can say reversely, the 13 CO has higher reduced mass as compared to mu 12 isotope of carbon and oxygen CO. So you can see here heavier mu, we know this, heavier mu is have higher values than mu lighter. So if mu is this and I direct proportional to mu, I will go as same, I will go with same. And since we know that b direct proportional to mu r square, h upon 8 pi square ic. So If is this, then reverse will be happen here. Means we are having for higher mass isotope, B will have less value. Now look at here. Suppose the white line is for 12 CO and green line is for 13, means heavier mass. So mu is higher for green than white. So for higher we will be less. So it will be shifted towards less value. So you can see here. And as we increase our transition, we are having that the shift will increase from its origin. Suppose this is 12, then here this is 13 CO. Get my point? Okay. But the relative width between two consecutive lines will be 2b. We have studies for rotational spectra. This. So the spectrum of heavier species will show a smaller separation between lines than that of the lighter one. Heavier species will show a smaller separation. You got this. Because it's 2b, separation is 2b. If b is less, then separation will be less. Now we will focus about non-rigid rotator. Till now we were studying rigid rotator, means the intermolecular distance between the atoms were not changing, but now onwards it's non-rigid, means it will behave elastically, means the distance between two consecutive atoms will change. Now till now we have studied rigid rotator, bone length will not change throughout the rotation, but now we are talking about non-rigid rotator, means the bone length are gonna be changing during the rotations. And the separation, this is the important part for us. The successive lines, this is to be of the spectrum decreasing steadily with increase in J. For non-rigid rotator, if you increase J, 2b will decrease due to centrifugal forces. Why it's happening? This is the reason. The energy levels of non-rigid rotators are h upon 8 pi square IC, J into J plus 1, and this is for non-rigid part. Correction will be there. H4 32 pi 4 I square K, J square J plus 1 square joule. After solving this, you are having two component. This was in joule, and for in centimeter inverse we will divide energy with SC. So it will come in centimeter inverse form. So BJJ plus 1 from here minus this part will be D J square J plus 1 square. Okay, so here new term will be in corrective form, which is D is centrifugal distortion constant. This is the value from here. And B, we know this rotational constant. Our most there is no need to introduction for B. We know it. It is a rotational constant. Now relation between B and D. This is D, and move omega y equal to vibration frequency of bond, K equal to force constant. Selection rule, non-rigid rotator, delta J equal to plus minus 1, same as rigid rotator. So delta J equal to plus minus 1, which is same, having the same value as rigid rotator. Therefore rigid rotator selection rule is also same like this. Now suppose we are having transition from J plus 1 equal to J, which is, this is for emission. For emission, delta J equal to minus 1. So what will be there? Just put the values here and calculate again, and you are having 2bj plus 1 minus 40 j plus 1 ka cube. Okay, so you can see here, as we are increasing J, this term will be increased, minus term will be increased, means mu J will be decreased. So thus the spectrum of elastic rotator is similar to the rigid rotator, except the one condition that each line is displaced slightly towards the lower frequency. We have seen that in our earlier slides. Now the displacement increases as we increase with J number. So the displacement will increase as we are increasing with the J number. Now we'll study about rotational spectroscopy. We know this B was this, EJ was this, and I was this. Now some questions will be there. Consider the hydrogen deuterium molecule, hydrogen 1H1 and deuterium 1H2 molecule of the mean distance between two atoms is given to us, and the mass of hydrogen atom is given to us in electron volt per c square. Then the energy difference delta E between the two lowest. What will be the lowest rotational state from J equal to 0 to J equal to 1? So what will be? So we know that the energy separation between these two consecutive lines will be B, J, SC, JJ plus 1, okay, which will be in joule. So delta is equal to 2b SCJ plus 1, which will be in centimeter inverse. 2b SCJ plus 1. So just put the value, means we are going from 0 to 1, which is the absorption, means delta J equal to plus 1. So just put J plus 1 equal to 1. So 2b SC will be answer. So 2b SC, and we know that the value of B is H upon 8 pi square IC. Getting my point or not? What was the question? In question we have to calculate the energy difference delta I of the two lowest levels. So the energy difference we know, this is that formula, delta is equal to 2b SCJ plus 1. Simply 2bj plus 1, but for centimeters we are multiplying it with SC. So just put the value of 2bj plus 1, just put the value and solve it. We are having I also, I equal to mu r square, and calculate this mu will play key part in this question. What is mu? Mu is for hydrogen deuterium molecule. So just place the value, hydrogen deuterium mass, and reduced mass will be 2 by 3, which is the mu. So to convert it into mega electron centimeter square, this will be the. So just put the value and you will having the answer 0.975 10 to the minus 2 electron volt. Now the first absorption spectrum of 12CO16 is 83842 centimeter inverse, while that 13 is this. So the ratio of moment of inertia in this question, the questioner is asking us about the moment of inertia. So we are having the question I13CO by I12CO. Now what is given to us? We have given to us this part, centimeter inverse, means we are having the rotational constant part 2bh and 2bl we are having. For higher mass lower, for lower mass it will be higher. B is inverse proportional to mu. Now I inverse proportional to B. So just put the value here, IL lighter by heavier, B heavier by B lighter. But in question we are having higher by lower, so higher by lower will be lower by higher. So just reverse it and you are having the answer 1.046. Now the diatomic molecule hydrogen fluoride has an absorption line in the rotational band at 40 centimeters. For the isotope 18F, the corresponding line for the isotope 19F will be shifted by experimentally. Again same question. So it is given to us that 2b is equal to this, and for 19 fluorine we are calculate 2b prime, but b is inversely proportional to mu. We know this, so mu 1 b1 equal to mu 2 b2. So b2 equal to mu 1 by mu 2 into b1, and multiplied both sides with 2. So we are having this. So 2b2 will be mu 1 by mu 2. Mu is for hydrogen fluoride for 18 and this is for 19. Just put the value, and we are having given to us that the value of 2b1 is 40, means for HF18 we have the value. Okay. So we are having 2b2 value is this, but in question it's not asking about the rotational constant per second. What is asking in question? He is asking in question the corresponding line for the isotope 19F will be shifted approximately. Okay, so how much it will be shifted? Delta shift will be there, 2b1 minus 2b2, 11 centimeter. Sorry, 8.11. Okay, now next question. The absorption lines arising from pure rotational spectrum of HCl observed at 830.03 and 103.70 centimeters. This was the some values given to us. The moment of inertia we have to calculate. Okay, for this substitution given to us. So nothing worry about. Nothing is to worry about. The rotational spectrum, we know that the difference between the two consecutive lines remains constant. So just minus any of this, and you are having 2b. The value of 2b is here, and b is h upon 8 pi square IC equal to 20.70 centimeter inverse. Just put the value, and you are having 20.70 centimeter inverse. So h by 8 pi square, h by 2 pi IC we are left with, and we have the value h goes upon 2 pi IC, 2 pi c. So I will be there, and put the value and solve the question. You are having the value of moment of inertia. Now the GATE 2020 question. Consider a gas of hydrogen atom in atmosphere of the sun where temperature is 5.00 Kelvin. If a sample from atmosphere contains this part in the ground state, the number of H atoms in first excited state is this. is this, it is given to us. So we have to just calculate the value of n. So we know that from Maxwell-Boltzmann's law, the relative population is this, and it is given to us. What is given to us? We are using the hydrogen atom from ground state and first excited, that is 3.4, 10.2 electron volt. So let's put the value. We are having also the value at ground level and the first excited level, which is 8 in 10 to the power 9. I think I am, yes, here it's 8 into 10 to the power 9. So just multiply it and solve this. You are having n equal to 14. Now 2005 get redo test there. Mass is given to us. The energy of first excited stage is given to us. So what is given to us? Energy of first excited state for rotator ground state J equal to 1. Sorry, J equal to 0 is ground and J equal to 1 is first excited. So just E2 is B and Bj into J plus 1. It is in electron volt. If you it is in joule. If you want it in centimeter inverse, let's multiply it with H into C. But for excited state force, J equal to 4, put the value 2B into 10. So 2B into 10, it will be 10 milli electron volts. Why I have not multiplied with 2? Because 2B remains constant throughout the transition. Means that energy difference remains the constant. Don't do mistake by multiplying with 2. If there will be option of 20, you must have ticked that. But this is not with the case. Because for here also we are having 2B equal to 1. So 2B equal to 1. 1 into 10 equal to 10. Now 2014 question. The moment of inertia of a rigid diatomic molecule A is 6 times of another rigid molecule B. IA is 6 times of IP. Now the rotational energies of two molecules are equal then. So rotational energies are equal. We know that EJ equal to BJJ plus 1 and B is proportional to I. So EJ directly proportional to J into J plus 1 by I. Now energy of A for A and for B part. For A is this and for B is this. But IA equal to 6B. Let's put the value and solve. We are in this equation. Check the option. Put J equal to 3 and JB equal to 1. So 3 into C plus 1. 4 into C 12. And put here 1. 1 into 1 plus 1 2. 2 into 6 12. So option D will be correct. Now we have studied this question. I already uploaded. I think so that I have uploaded. But let's discuss one again. One of the following is a non-polar. What is a non-polar? No separation of charge. It will be well dissolved in non-polar solvent. And non-polar solvent are organic compounds. So CO2 are having permanent dipole, but this is not having CO2 is not having dipole. With which type of spectroscopy would one observe the pure rotational spectrum of H2? So pure rotational of H2 we are using Raman spectroscopy. And B is inversely proportional to I inversely proportional to R square. So B inversely proportional to R square. The successive rotational levels in case of a simple diatomic molecules with permanent electric dipole moment are separated by permanent electric dipole moment. So diatomic equal to B and I H upon 8 pi square C into I. Getting my point? In this case, separation we have to calculate. So Bj into J plus 1. And the correct option is R H square upon, if you say J into H square upon I. We are using J and he is given to us J into H square upon I. It is the proportional sign. The rotation spectrum of molecule is sensitive isotopic substitution of atom in the molecule if the ratio of the 13 and 12 is 0.956 given to us. Then the same question we have done this. Like this, isotope for isotope. mu1 b1 equal to mu2 b2 and then we have move forward. Same here, I13 and I12. I2 over I. So simply 2 I inverse proportional to B. Here also I inverse proportional to P, and here reduced mass will be there for isotope mu1 B1 equal to mu2 B2. So two types of questions are there. So it will 0.956. The rotational spectrum of 12 and 13 CO provides the value of rotational spectrum to B is mu1 B1 equal to mu2 B2. Put the value, solve. Relative intensity of successive lines in the observed Raman spectra. We have not studied Raman spectra so far, but the question you can see here. I will explain it when I uploaded that video of rotational spectra. Now, from now onwards, we are going through vibrational spectroscopy. Thank you very much for your patience. Share it with your friends. Thank you very much. Bye bye.